Hello. I'm clearly not with you guys again. I have not gotten better enough to come back in yet. So I will show you, I'll teach you the next lesson this way. And then we'll pick up when I get back, hopefully Wednesday. So we've been talking about proportional relationships. And now we're going to take a next step and look at it. Where do we actually use it in the real world? What are different ways that we can identify proportional relationships? So one of them, for example, is with a plane. That's why I put this up here. The lift that the plane has is in direct proportion to the surface area of the wing. So if you increase the area of the wing, you're going to increase the lift by a proportional amount. So we are going to look at proportional relationships in three different ways. The first one we're going to look at, I'll just give you an idea. These are all going to pop up. The first way we're going to look at it is looking at it in a graph. Okay. So there's two parts to a graph. First one is it is a straight line and it goes through the origin. Okay. So if it goes to the origin and is not straight, not proportional. If it is straight but not through the origin, not proportional. So what do I mean by that? If I had a line like that, that's straight, but it does not go through the origin, so therefore it is not proportional. This is a big old fancy term. There's this thing in here called the constant of proportionality. I'll show that to you on the next slide, what it actually represents, how we get it. It's actually the relationship between the y value and the x value. Okay. In order for it to be proportional, it has to be constant, hence the word constant of proportionality. We'll cover that on the next slide. Sometimes you might see it look like this. This would be the graph of or the equation of a graph that's proportional. You can see it right here. We'll talk about what that is on the next slide. So like I said, there are three ways to determine whether a relationship is proportional. First way is in a graph. So like I said before, it is a straight line and it goes to the origin. Okay, why do I only have one quadrant here, not four? Well, we're talking about distance and time. You can't have negative time. So sometimes you can only have just the one quadrant. Sometimes you can have all four like you did on the last slide. The equation is y equals kx, and k is the constant of proportionality. I will show you how to calculate that. Super simple. And finally, the last thing is to find it in a table. Hint, this one's not proportional, but that's okay. So we'll look at all three of these as we go through. Okay, so the first one we're going to look at is a table. Table is really simple. Okay. And a relationship is proportional based off of the y coordinate, okay? And you divide that by the x coordinate, okay? Y divided by x. It's actually called dependent variable divided by independent. We'll cover that later on, okay? So y over x, right? So if you divide y over x and you get the same thing each time, it is going to be proportional. So negative 2 divided by 1 is negative 2. Okay, 0 divided by 2 is 0, so that doesn't work. 2 divided by 3 is 2/3. 4 divided by 4 is 1. Each time I divide the y by the x, I'm getting something different here. Because it's different, it is not proportional. It is only proportional when it is the same. Now, obviously, you can't do 0 divided by 0. We know that, but it has to go through 0, 0 in order for it to be proportional. So if we do y divided by x here, we get 2 over 2 equals 1, 4 over 4 equals 1, 6 over 6 equals 1. Every single time we do it, other than the origin point, we get the exact same number. Therefore, this is proportional. That's all you have to do, figure out from a table. Okay. All right, let's look at this one. All right, so y divided by x. Well, at this point, you already know it's not proportional because it has to be x0, y0. It's not, so we can't. But just to prove it another way, 1 divided by 1 is 1. 4 divided by 2 is 2. 7 divided by 3 is 2 1/3. You can see each time it does not come out to be the same. So this one is not proportional. Let's come over to this one. Now, it doesn't give you a 0, 0 point. Doesn't mean that it can't be proportional. So we'll do the y divided by the x. Okay, so 4 over 1 equals 4. 8 over 2 equals 4. 12 over 3 equals 4. 16 over 4 equals 4. So you see, every single time when I divide the y coordinate by the x coordinate, I get 4. Okay, so that tells me that this is proportional. And the other thing that it tells me is that 4 is your constant of proportionality. I'm not going to fit it on here, so I'm just going to put a little dot there. Okay. Now we have a special variable for constant of proportionality, and that would be k. Okay, so we would say k equals 4. We're going to find out as you start getting a little bit further in math is that certain variables are utilized for certain things. So that way it's just a lot easier to understand. So k, one of the things k is used for is constant of proportionality. It's used for something else in physics, but you don't need to know that right now. Okay. So one of the things I showed you on the last slide was the equation of these lines is y equals kx. So y is what's called your dependent variable. The reason why it's called your dependent variable is because it depends on what your x variable happens to be. Okay, so whatever number you put in for x, you can calculate for y. So y is dependent upon x. So k gets put in right here as your coefficient. So the equation for the line, for this proportional line, would be y equals my constant of proportionality, which would be 4x. That's it. No more. Y divided by x, if it's constant, that's your constant of proportionality. When you put it into equation, y equals that constant of proportionality times x. If I come back here, okay, my constant of proportionality here is 1. Okay, so I would write this as y equals, now, 1 times x. I'm putting in parentheses for a reason, because we know that when you multiply by 1, we don't write it. So this would just be called y equals x, because we know that that constant of proportionality is actually 1. Okay, let's look at this one. Okay, y divided by x again. So 4 divided by negative 2 is negative 2. 2 divided by negative 1 is negative 2. Now here's the thing, you have to do all the points. 2 over 1 is 2. These are not the same. Okay, this is a real graph, by the way. It would look like this. I have something. It's basically absolute value graphing. You won't get to that until you get to algebra. So anyway, this one is not proportional. Okay, so now let's look at this one. So this is proportional, okay, because it is a straight line and it goes through the origin. So what is it showing us? The graph shows the speed of a subway car. Find the speed in miles per minute. So it tells you right here, your y is miles, your time is minutes. And it even told us what it wants it in, miles per minute. So I need to do a unit rate, all right? Now, I can choose any of these points. This is the easiest point, all right? If I do 1/2 over 1, so 1/2 mile in a minute, okay? So this would be y divided by x would happen to be 1/2. Okay, so it's 1/2 miles per minute. Now, if I needed to write the equation for that, the equation is always in the form y equals kx. So y and x always stay as variables, right? They don't change. However, other variables that are in there, we change. K changes. So what goes in here? 1/2. So this will be y equals half x is my equation. And what it means is that, the subway car goes 1/2 mile every minute. Now, I had mentioned, does it matter if I choose the points? And I had said no, because every time here, I'm going to get the same thing. So let me choose this point right here. Y over x is going to be 1 over 2. Okay. So 1 over 2, okay, 1 mile in 2 minutes simplifies down to 1/2 mile per minute. I get the same thing. If I were to do this one, I'm going to get 1/4 over 1/2. Well, multiply both by 2, and what do I get? 1/2. So it doesn't matter what point you pick. Every single point, if it's a proportional relationship, will give you the exact same relationship. Y divided by x will always be constant. Okay, use the graph shown to tell whether x and y are proportional. Okay, well, I think you figured it out. The answer is, of course, y. It's straight, and it goes through the origin. Okay. What is the equation of this line? Well, all we have to do is take any 2 points that we have. Now, they tell us specific points, which is nice. So it gives us 1.5 over 1, or 4.5 over 3. Either one, it's going to give us 1.5. Okay, in this case, it happens to be inches per second because it tells me that right there, inches per second. And this is going to be 1.5 inches per second. Now, on here, if they don't give you the points, all you have to do is find points. Okay, what is this point? 3/2. What is this point right here? 6/4. Well, each one of these comes out to be 1.5. So any of these points that you can find will work. So if they don't give you the points, you just find where you can guarantee 100% where you know where the point is, aka when it goes through an x and a y line. So what would the equation be? Well, keep doing this. Y equals kx. My k is always going to be my y divided by x. In this case, it happens to be 1.5. So y equals 1.5x. Now, I don't label this with like, oh, 1.5 inches per second. That doesn't work. Okay, up here it matters. But your equation of the line doesn't get a label. It just gets letters and numbers like this. All right, when you're interpreting a point on the graph, yes, you need the labels. All right, so if it said, oh, interpret this point right here, which is 2, 3, you'd say, oh, it goes 3 inches in 2 seconds. All right. Hopefully that makes sense. Interpret each plotted point in the graph, then identify the unit rate if possible. Well, I sort of did that before on the last slide. Okay, so this means right here, 0, 0. I go 0 inches in 0 seconds. 1.5. Well, it means in 1 second. The distance traveled is 1.5 inches. All right, let's look at this in real life. Like one of those Roombas or whatever you have, those controlled autonomous vacuuming things. So the graph shows the area Y in square feet that a robotic vacuum cleans in X minutes. Find the area cleaned in 10 minutes. Well, it doesn't give me the area cleaned in 10 minutes. Okay, I get 8 to 1.5, 16 to 1, 24 to 3/2, 32 to 2. But what we know is this is a proportional relationship because it is a straight line and it goes through the origin. So in order for us to do that, we need to find the unit rate, and we can pick any of these points to help us find the unit rate. Let's use the easiest one, which is 16 feet squared to 1 minute. Oh, wow, look at this. It's just a proportion. How much in 10 minutes? Obviously, it's going to be 16 times 10, right? So we're doing by 10 over 1. So x equals 160 square feet. What would the equation of this line be? All right, remember, y is equal to the constant of proportionality times x. Constant of proportionality is y divided by x. Every single one of these is going to give me 16. So y equals 16x. Okay, so that is all we are going to do for today. So just to reiterate, 3 ways that we can look at proportional relationships. 1, in a graph, if it is a straight line and goes through the origin. 2, in an equation, okay, if it's y equals kx, basically y equals a number times x, proportional. And last but not least, in a table, it is y divided by x. If that is constant every time, then you have a proportional relationship. All right, hopefully I will see you very soon. Bye.